Greetings, I am Ixora Kapple.
I am IZZUDDIN SOFI.
And today we're going to present about our FYP1, which is entitled UMSKAL Interactive Navigation Simulation using Maya 3D Primitive Polygonal Modeling.
So firstly, our project research here is navigation simulation, which is a mobile application of a 3D model of Menara UMSKAL to ease students' navigation in Menara, and our project is built using 3D Maya primitive modeling technique.
So why did we come up with this kind of project? This is because we have discovered certain problems and we would like to solve those problems. The first problem being, navigating around Menara UMSKAL is still difficult for students even after their first year. Results of our survey shows that 58% of our respondents still did not get to navigate around Menara without having to ask for locations or directions even after their first years.
Secondly, our second problem statement is absence of a navigation system to ease navigation in UMSKAL. 39 respondents, which is 78% of our respondents, prefer having a navigation simulation system rather than the paper maps they provide students during orientation week. Paper maps are very weak and they can break easily and they can damage easily. So that's why we propose a navigation. Next, our objectives. So based on our problem statements, we have come up with two objectives, which are to probably and completely inform students about locations in Menara so they get to understand and familiarize with the building quickly. Secondly, to create a navigation simulation to ease students' navigation in Menara UMSKAL.
So, in our literature review, we've covered two main keywords, which is navigation and simulation. As you can see from our report, we have covered the definition of simulation, the definition of navigation, and also how navigation and simulation works together to combine a perfect simulative navigation system, which we will be implementing in our project soon.
We also researched on 3D modeling, the techniques used in 3D modeling, which one is the best for our project, which is primitive polygonal modeling. We compared which techniques are best in the softwares. So we came up with Autodesk Maya, Rhinoceros 3D, and ZBrush. The best software to suit our use of primitive modeling is Maya 3D.
So, in our methodology chapter, we have conducted a quantitative survey to gather data and information for our system. We did this by distributing questionnaires to 50 students from their second, third, and fourth year.
Our research and approach strategy, we used quantitative and qualitative data collection to analyze our qualitative survey. The methods we use for our product development, software development lifecycle, we use waterfall technique, which starts with requirement gathering, where we gather information on UMSKAL, to system design, where we design how we want our system to look. Next, we go to implementation, where we implement and do our prototypes, and we test. After testing is okay, we deliver the product, and next we have maintenance. It all goes back to the up. Our product will first go through 3D modeling in Maya 3D, and after 3D modeling is done, we will convert the object to 3D objects and use them in Unity 3D to create our navigation simulation. Next, we can present our analysis and design chapter. For our questionnaire, 70% of the respondents were FKI students and 30% of them were FCAL students.
And as for the next chart, this figure shows that 68% of our 50 respondents are third-year students, while the second-year batch holds a percentage of 24%. 8% of our respondents are from the fourth-year batch. This shows that most of our respondents are third-year students. The figure above shows which year exactly did our respondents finally could familiarize themselves in navigating around the Menara. Most respondents could finally navigate around the Menara without having to ask for directions or referring to any physical map when they were in their second year studying in UMSKAL. This data stands at 46%, whereas 42% of our 50 respondents can navigate around the Menara independently during their first year. 10% of them could finally navigate around the Menara without any aid in their third and fourth year. Overall, this shows that 58% of the respondents did not get to navigate around independently in their first years. So the next data covers which departments in Menara do students find it hard to navigate in. As you can see from the chart, 68% of our respondents find it difficult to navigate in the lecturer's office in both FKI and FCAL departments, whereas 46% of them are not familiar with navigating around the various labs, which we have in the Menara, whereas the lecture hall stands at a value of 32%. The rest of the departments stand at 4% and 2% respectively. This data allows us to focus on which departments we should develop in our interactive navigation simulation app. As for the system design section in our questionnaire, we asked the students whether they prefer an interactive navigation system instead of paper maps provided during orientation week. So, therefore, from the chart shown, you can see that 78% of our 50 respondents preferred an interactive navigation system, while the rest are okay with using physical paper maps. This data proves the need for developing a more reliable technological navigation medium as opposed to a printed paper medium. We also asked if students would prefer a virtual simulation tour or an interactive map of Menara UMSKAL. We discovered that 68% of the respondents prefer an interactive map, while the rest of them, which stands at 32%, prefer a virtual simulation tour. This is a positive result to the development direction of our app, directing our development to be an interactive map. Following our previous question, we asked the students what kind of application features would they like to exist in our navigation app. 60% of the respondents would like to have an option of zoom functions, which would allow them to focus on either the details of a particular region or to gain a quick overview of a more extensive area. 56% of them would like the addition of text boxes to data points that show up when clicked to give a quick summary or description. The option of having the ability to create layers of information that can be shown or hidden at the click of a button stands at a value of 54%, while at 50%, respondents prefer to have points on the map which can be linked to external supporting documents such as images, video, or graphs. The rest of them would want to have an interface that is just easy to use and which is simple for them to understand. The last but not least question that we have asked for our quantitative survey is which platform would the students prefer for our simulation app to be available in? We gave two options, which are mobile phones and computers. It has shown that 96% of our respondents prefer our simulative navigation app to be mobile compatible, whereas only 18% of them prefer the latter option. This data points to a direction where we must develop our app for a mobile platform instead of computer platform. As for future suggestions, we managed to accumulate 4 leading suggestions to add in our application for future development. These suggestions include gamifying our app, having extra add-on features like options for voices, and adding an information counter, making our app compatible in both iOS and Android mobile operating system, and lastly, making our app more user-friendly. This figure shows the flowchart that will be the process the user goes through when using this simulation application. The application will start with the main menu, where users are prompted to choose between Start, Options, and Quit. Quit terminates the application, while the option allows the user to change volume. Once users pick Start, they will be brought onto the lift, where they have to choose a floor to navigate to. When on the floor scene, users are prompted to decide if they want to interact with objects to display more information.
Next, we'll go into the interface design of our project. So when the students, this is our prototype. of our UMSKAL interactive navigation simulation. So when the students open up the application in the mobile phones, they'll be greeted with this main page. In the main page, students can see more info about our application and how to play. So how to play is students use the left button here to walk around, and there's another button to interact with information, with objects that reveal information, and also this right area of the screen, phone screen, is to look around. Going back to the main menu, there is an option for the volume where students can choose to scale their volume from off to full, and students can start their navigation. When they press start, they will be brought into this lift menu. In this lift menu, they can choose which floor they want to go to. So let's say the student wants to go to 5th floor, and they will be brought onto the FKI department. They will give information of what floor they are on to remind them. And this is an example of what the 3D scene of FKI floor will be like. So how the student move around, you can use this to walk around, and when they get nearby an information, they will have a trigger here saying the student can interact with the information. See, when the student goes back, due to the distance, the information is gone. So when they go near, they can interact. Say they interact, and here, when they press the interact button, there will be an information pop up saying, giving explanation of what this place does, what you can do here, and also what time it is open. Yes. So students, when they are done with the lift, with the floor, they can go back to the lift and choose what floor else they want to go to. So that will be how that is how our application will look like. Students will quit if they are done.
So that's all that we have from our data collection to our prototype examples. So as a conclusion, we have decided to begin the development process of our navigation simulation in such a way which will meet our questionnaire data standards from design to functionality. The data with the highest percentage will be taken into consideration and developed respectively according to our process flowchart. Future suggestions will also be implemented after beta testing. We have reached the end of our video presentation, and with this, Muhammad IZZUDDIN, SOFI, SABRI, and Ixora, Kaylyn, Kapple, we would like to say thank you to our examiners for taking time to watch our video presentation. We will be looking forward for your feedback. Thank you and take care.